Okay. So now let's look at similarity between clusters. How do I measure the similarity between clusters? Because that's what the algorithm uses, yeah? So given 2 points or 2 clusters, right, measure the similarity between them. How do I measure similarity between clusters? Any thoughts? So how do I measure the similarity between these 2 clusters, for instance?
The distance between them?
The distance between what?
The clusters.
Yeah, how do I measure distance between the clusters? So I have 4 points.
No, I think each cluster we measure the distance between their points and the centroid. We get the one with the minimum.
But I want to measure, right, these 2 clusters, right? This is closer to this, or this is closer to this. So the one horizontal.
Oh, centroids. We just measure centroids distance.
I can measure the distance between the centroids. That's one approach. Yes. So I compute the centroid of this cluster, centroid of this cluster, centroid of this cluster, and then measure the distance between the 2 centroids and take the one that have the closest distance. That's one approach. What else? I could also measure the distance between the points here, the points inside and the points inside, right? And say, okay, take the maximum or the minimum distance or the average distance as a measure. Yeah, so I could use the centroids, that's the most intuitive thing, but I could also use other techniques. So what is called single link means maximum similarity between instances of the clusters. Yeah, so I measured the maximum similarity between every pair of, I measured the similarity between every pair of points, xi and xj, where xi belongs to cluster ci and xj belongs to cluster cj. So I have, I pick a point from one cluster, a point from another cluster, all right, and compute the similarity between them. Then pick the 2, the maximum similarity between among all pairs of points. Yeah, and that gives me a similarity between these 2 clusters. So, and then based on this, I pick the clusters with the closest distance. In other words, I have these, 4 clusters or 3 clusters. I'll measure the distance between, similarity between this and this, similarity between this and this, similarity between this and this, and then pick the maximum similarity. It will happen to be this and this. Right? These are the closest 2 points, so they have the maximum similarity. So I measured this value, keep track of it, measure the similarity between this and this and this and this, and then the maximum similarity would be between these 2 points, and then pick the one which have the smallest maximum similarity. The largest maximum similarity, yeah, that would be the closest one. So in that case, it would be, I would pick these 2 guys. Okay, so that's called single link. Complete link, minimum similarity between instances of the clusters. And the idea is I want clusters for which the minimum members are really close to each other. Yeah, the ones that are furthest away from each other are close enough. Yeah, so I pick really based on worst case scenario. So I compute the similarity between every pairs of points, one in one cluster and one in another, and then pick the minimum distance or the minimum similarity as a measure of similarity between the 2 clusters. Yeah. The third thing is to do group average. So I average similarity between instances of the clusters. So I pick a point from one cluster, a point from another cluster, compute the similarity, and average this over all number of pairs of points inside these 2 clusters. And finally, the centroid similarity, which what you guys suggested in the beginning. So basically, compute the similarity between the 2 centroids of the 2 clusters and use this as a similarity measure between the 2 clusters. Okay. Of course, similarity could be cosine similarity, Euclidean distance similarity, Manhattan distance similarity, etc. So this, doesn't bound us to one particular similarity measure. So if yes.
But isn't the Euclidean distance similarity and the cosine similarity, like they all return the same distance, right?
Yes, but they have different values. Yeah. So
yes.
Yeah, and they could have. Remember, we talked about cosine similarity being. I don't think in this course, in another course, in the IR course, none of you have taken the IR course, but we talked about Euclidean similarity versus cosine similarity, and they tend to have different properties for them, right? So, for instance, right, if you don't do length normalization, then cosine similarity is better than distance similarity. Yeah, because the vector, right? They could have 2 vectors. One is very long and one is very short. the Euclidean distance between them would be large, whereas the cosine similarity would be small if they are similar but they have repeated words, for instance. So let's say you have two documents you want to cluster and you're using Euclidean distance. If one of the documents is too long but it repeats the same information as another short document, they might be considered very different. In cosine similarity, they wouldn't be considered different. Yeah, so they have different properties.
Yes.
Okay. So here's looking at complete link HAC. So if I try to hierarchically cluster this data set using complete link, which means that I'm looking at the minimum similarity between two clusters. So I pick these 2 points to to cluster first, then these 2 points, then these 2 points, then these 2 points, because they all have the same minimum similarity. Then I'm gonna take these 2 clusters to merge rather than these 2 clusters, because I'm looking at complete length. So I look at the largest distance, right? So basically it will be between these 2 points, yeah? And this is smaller than the largest distance between these 2 clusters, yeah? This is smaller than this. And so I pick these 2 guys to merge first, and then I pick these 2 guys to merge first, and then I pick all of them. Again, this is a hyperparameter. You should try different, similarity techniques, and based on this, decide what is the best approach. Okay, final thing, and then we're done. So the last slide. So using HAC for flat clustering, hierarchical clustering for flat clustering. By flat clustering, I mean, fixed number of clusters, and you have a particular number of K, you don't have this hierarchy, yeah? So again, I'm giving an input space which contains D features and a data set of endpoints and a similarity threshold tau. Okay, so I'm gonna use the similarity threshold tau to kind of drive the clustering approach. So what do? I start with every instance in its own cluster, and then among the current clusters, pick the 2 clusters that are the most similar, so similar to hierarchical clustering, and replace Ci and Cj with a single cluster. And I keep repeating this, but not indefinitely until I have every point, all the data in one cluster, but until the similarity between every pair of clusters is greater than or equal to some threshold, right? So basically, I cannot, I cannot find any 2 clusters that are close enough. So I keep, merging until I have no more 2 clusters at all in my data set that are close enough to merge based on some threshold tau. Once I have this, I just return the top level clusters. So what I have arrived to so far, yeah? So what I've merged into, if I've merged 2 clusters, then I return the merged clusters and so on. Yeah, this is a way of figuring out automatically the number of clusters. On the other hand, I have to specify this threshold tau. Again, so this is a hyperparameter. I can try to learn it based on different values. So I try with different values, compute the clustering, and see the cost right through this elbow curve, and see if you have a better cost with different threshold values. That's pretty much it. You have as far as I remember, you have an assignment on this and on dimensionality reduction and anomaly detection, and as the last assignment. You have questions? Easy, right? This part is easy, I assume. Okay, I think you're gonna use a library for this, so no real. You're not gonna implement it from scratch. Yes, Firas? Yeah, it's easy. Yeah. Okay. Cool. Any questions, guys? Okay, so then I'll talk to you on Thursday. We'll talk about I think dimensionality reduction on Thursday. Again, very important topic in unsupervised learning. Okay, thank you.
Thank you, Professor.
Yalla.
Thank you, Professor.
Assignment, the new assignment is out, right? So today, so please start.
Yes.
Okay, good. See you guys.